Okay, the first thing that I want you to remember for today's lesson is that whenever we have two standard deviations, whether we're subtracting or adding, we square them both. So remember, if I had SD is equal to 3, and I have SD of 1 is equal to 3, SD of 2 is equal to 4, and I wanted to know, and I said x1 plus x2. And so remember what we would do is that we would say 3 squared plus 4 squared is equal to 9 plus 16, so that the variance of x1 plus x2 is equal to 25. And so the standard deviation of x1 and standard deviation of 2 is equal to the square root of 25, which is 5. And remember, that worked for whether we were adding 2 or we were subtracting 2. Okay, so today's lesson, you need to keep that in mind, is on two proportions. And we're just going to do confidence intervals. Okay, so there's a problem in the book, and it talks about who's more intelligent, males or females. I'm going to have, this is the proportion of smart men, and PF is the proportion of smart females. All right, and so what did in the book they said that the smart males, I have to go look it up. 28% of 506 males said they were smart, and of the females, 14 of 520 said they were smart. Okay, so let's go do the math. So the first thing that we need to do is that we need to say we're doing a 2 prop z interval. We need to do conditions. I believe that they said that they were chosen randomly. Okay, so my 10% condition, you can do them all together or you can do them separate. So 506 plus 520 is less than 10% of all males and females. All right, now what we have a new group called independent groups. And whenever we are doing 2, we have to prove that one group does not influence the other group. So we would have to say that the smart males does not influence smart females. Okay, this is a new one. Okay, next is the last one is success failure. Go up there. Okay, so what I'm going to do is going to n times PM. So this is going to be 506 times 0.28. Which is 141.4, which is greater than 10. And n times QM, right, for the failure. So 506 minus that. And I get 364.6 is greater than 10. And let's do the females, and oops, these are all hats. Right, because we don't know the truth. So this is n times PF And so this is 520 times 0.14. And I get 72.8. And this is going to be 520 times 0.86. And I get 447.2. Okay, so all of these are all greater. Oops, I forgot to put greater than 10. Shame on me. So the conditions for a normal distribution exist. All right? So now let's go do the math. So the math is going to be PM minus PF P hat plus or minus my z-score P hat M Q hat M N M, the N for M, plus P hat F Q hat F over NF. Okay, this is a 95%, okay? So what do I have? So this is going to be 0.28 minus 0.14 plus or minus 1.96. I am not going to get this all in here. So this is what, 0.28 times 0.72 divided by 520 plus 0.14 times 0.86 divided by 506. Oh, I'm surprised. Okay, now I'm going to go to my calculator and find out what the answer is. Okay, so when you go to your calculator, you're going to go to stat, and you're going to go to confidence intervals, and I think it's number 6. You're going to go to 2 props, okay? So when I did this, I got 0.0930 to 0.1913. All right? And so let me write my conclusion. And so say we are 95% confident that the true difference between, okay, now I need to go to the next slide. The proportion of males who are intelligent, but I'm just going to write smart, and the proportion of females who are smart is between, and so what do I have, 9.30 to 19.13%. Okay, I'll have your homework on the board. Okay, it's just a couple of the problems of confidence intervals. Good luck.